So in this first video of the unit, we're going to look at how to remember a picture, and hopefully from the practice that you did before this, you kind of have an idea. But the key question is how do we translate an image into numbers? So that's what we're going to be thinking about this whole time, is how do we take an image and make it into numbers. So to remember a picture, we're going to start with a picture. So I've just slapped this picture of a picture over here on the right. And the first step is to break that picture up into pixels. So if you're taking a picture using like a digital camera, right, on your phone, that's going to do the breaking up into pixels for you based on how many sensors there are. So, that's why we say we measure the sensor size in megapixels, or that's millions of pixels. So how many pixels there are is just where they are. But if I wanted to break this up into pixels, you can imagine, making a grid here. Say it was something like this. We'd also have our grid lines like this. And it's a sloppy grid, but you can get the idea, right? We go across, and then we can come down. And so you can kind of see how this could be broken up into a bunch of little pieces of a grid. So we've broken that up into pixels. And then next, you assign each pixel number, and this will be based on brightness and color as relevant. So if it's really bright, it'd have a high number. If it's really dim, it'd have a low number. So in this case, all these pixels around the outside here, these would all get a high number because they're quite bright. This pixel right here would get a high number, and then these two pixels would probably get a high number, this one get a high number, You'll notice it kind of, as it breaks it up, it has to kind of make a decision as to whether to make something bright or not. And so you see that if you can kind of look at this grid, you imagine that it kind of squares it up and we lose some of the detail. But that's because, we only have so many pixels to work with. And then you store this list of numbers, and that's your image. So this might be, 1, 1, 1, 1, 1 all the way across the top, then 1 followed by a bunch of zeros, and then a 1 at the end, 1, 0, 1, 0, 0, 0, 0, 1. In reality, we're usually going between 0 and 255. And so because this is kind of a pretty light gray, it might be 240 or something. But the main point of it is that you're just looking through each of those pixels and then deciding a number to assign it. And then if you store all those things, then later you can go back and basically recreate how much light should be in each of these pixels. We'll talk about color images a bit later, but you can kind of imagine how for color, like you saw, our eyes just see a combination of 3 colors, or a camera sensor just picks up the 3 colors. Same idea here. Okay, so types of images. If it's stored as pixels, so like we've talked about already, those are known as raster images. So if you've ever seen that term, that's what this means. It's that it's stored as a collection of pixels. There's a different kind of image known as a vector image as well. And this is a special digital only, like it has to be made on a computer to start. You can't take a vector image. You have to create one using math. And that's because these images are stored as equations. So for example, if you wanted to have a circle, a raster image would involve, laying a grid over this and assigning pixel values. But if you remember from a math class, or if you haven't learned it yet, you can also describe a circle using an equation. X squared plus y squared equals r squared. And so what you can basically do is say you have a circle, then in the middle of the circle you want to draw a line through it, and then you want to have, you know, two smaller circles here. And you can imagine creating an image from this. You can also then say, and then color in everything down here and create kind of a electrode looking creature. But you get the idea of, I can describe this as a big circle, two small circles, a line, and then color in a specific region. So that can all be described perfectly mathematically. And that means I don't have to store all those pixels. And also, as a result, it can be scaled infinitely. I can make this as big or as small as I want, and I won't lose detail, because if I make it bigger, I can just say, hey, draw a bigger circle. And the computer can know, okay, if I want it twice as big, I draw the circle twice as big. Raster images, if you want to scale those up, say you started with something that was like 1 pixel, you know, a tiny little pyramid like this. And that might look pretty much like a triangle, but when you make it bigger, you don't get any extra data typically. So it ends up looking much blockier. So when we say that a picture is pixelated when you try to blow it up, that's because they don't have any extra data to fill in these gaps. Like maybe theoretically you'd want to have, you know, this filled in like that to make it more triangular shaped, but we don't have that data. Now when we get to artificial intelligence later on, we'll see where a computer can kind of learn to guess what should go in there. But the point is, raster images have a limited amount of data. So when you try to scale them up or scale them down, they can lose some of the detail that you would want there. Vector images, on the other hand, don't lose that because they're described with math.